aspects of the previous class. I have also sent some sample problems and also a video of the discussion that we did last time about prime numbers. So you can actually look at how large these prime numbers are and also indulge in the discussion that is there in the video. We look at some additional properties of matrices first, and then we look at those problems for today. So I'll share my screen. I hope this is visible. Yeah. So let us start with a 3 cross 3 matrix once again. So yeah, this is how you write it for those who can't remember. So we have created our 3 cross 3 matrix. And now there are some operations that we would usually do in the when we are using matrices. So the first one is summation, and this time we did cover summation last time. So summation of A is like summing up all the elements of the matrix, but sometimes you would need summation in a particular direction. So for instance, if I want a row constant summation, I would do something like this. So you can see here. So it is summing up through all the columns, sorry, through all the rows, and a single column has been utilized. So 12, 15, and 18. So if you sum them up in this direction, that is vertical direction, you get this. You can also say sum of a comma 1. These both are similar. So either you write r or you write 1. Or for columns, if you want to change the direction, you write C and here you write 2. So let me clear this once again. Print A and go back here and write C. You would see that it's summed up in this direction. So you have 1 plus 2 or plus 3 is 6. 4 plus 5 plus 6 is 15. And similar for 24. And you can also write this as sum of A comma 2. It's going to give you the same thing. So this was about sums. Then you also have means. So we had A, you can write the mean of A, it gives you 5. So it adds up all these numbers and divides by the number of elements. So in a similar fashion, we would also like to find the mean uh, that is calculated vertically and also horizontally. So these things are quite useful for our calculations. We do come across them a lot. And now, for instance, yeah, so this is one major thing. The second thing that we would like to look at is appending and deleting elements in a matrix. So let me clear the screen, print what A is. And now I would say I want to append another column. So I would write 10, 11, 12. And once I'm done with this, this is my um, additional column. And then you would do something like A, B. Yeah, A comma B, sorry. So you are appending a column to this. So now you can see how this thing has changed, A, B, and AB. In a similar manner, you can also delete this entire section. So if I say, so I let me clear this once again. A is this thing, B is this thing. Let me say C is A comma B. So I'm putting this 10, 11, 12, appending it at the hind side of this matrix. This is going to be this. And now if I want to remove an entire row, let's say I'm removing row number 2. So I would say C sorry, column 2. For column 2, you would say all rows, column 2. And then to delete it, just open and close this. Once you do that, you can hit C. You will see this thing has vanished off. So in this manner, you can either add or delete anything with rows and columns. If you want to append um, another row, so let us call that as row number D. D is going to be, it's clear once again, CLC. This is C. D is going to be another row. So I would write it as 13, 14, 15. So this is D. I want to append C to D. So I would say an E matrix is C semicolon D. Now you can see this has been appended here. The same fashion, if you want to delete, let's say, row number 2, you do E of second row all columns, and this is deleted. So you can see it's gone now. 4, 6, 11 has gone. So is this clear to you all? You'll be doing this lots. Is it clear? Um, any doubts here? Okay, good. Yeah. So this was with matrices, and then even for vector, it's going to be the same. So we had, yeah, so let's consider this. This is a vector. So for vectors, again, can just say D is equal to D and then comma, uh, and then open 16, 17, 18. You can increase the elements here. Or you can also do, if you want to just post append, just say that this is 19. You can directly add another element without reshaping your matrix. So just use the dollar sign, because dollar sign is going to be the last element. You add one more element to that, and then that gets appended. You want to remove the first element, just do this, and it's gone. The same logic applies for both matrices and vectors. And now for this vector, there is another thing that we usually are interested in. So let me add another, I mean, these are all in sequence. So let me add something that is not in sequence. D. And now I might want to take the differences of these elements. So here 15 minus 14 would be 1, 16 minus 15 would be 1. Here 21 minus 19 would be 2. Here it is 4 and also 4 here. So you need something that can calculate the differences. So you just hit this formula, you can see these things. So you will always have one element less since you're taking the difference. So that is about these matrices. Then you also have matrix multiplication. So if you see this A star A is going to give you the actual multiplication of matrices, but sometimes we just need element-wise multiplication. Let me clear this, display A. So sometimes what you would want is you have A and A transpose. Let me just multiply both of them. A transpose is this thing. Yeah. So now what you want is you want to multiply 1 with 1 and you get 1. And you want to multiply 2 with 4 to get 8. 3 with 7 to get 9. The multiplication symbol that normally we use in SCILAB is going to like take 2 times 1 plus 2 times 2 and then 3 times 3 and then sum it up. The normal matrix multiplication that we do, that thing it will do. But at times we need something that is known as element-wise multiplication. So every element is just multiplied with each other. So in this case, what you do A, then you do dot star. Instead of star, you would just press dot star and then do this thing. You can see you got just one because one has been multiplied with one to get one. Two has been multiplied with four to get eight. And here nine has been multiplied with nine to get 81. Eight has been multiplied with six to get 48. So this is something known as element-wise multiplication. You can also divide element-wise to get these values. Yeah, since they are transposes, you can see that the diagonal elements are one. Yeah. So this is about element-wise multiplication and division. You can also power it element-wise into a square like this. Every element has been squared. So just bringing back a once again. So each element has been squared in its own place. So 3 square is 9, 9 square is 81, and so on and so forth. So this is about element-wise operations in matrices. And also the same is applicable to vectors. I would leave that for you all to discover by yourself. It is the same stuff. So you can look at that. And then once that is done, yeah. The other things are initialization of certain stuffs. So for instance, you want to initialize a matrix. So you just write zeros, 3, comma 3. So this gives you a zero matrix. And then sometimes you need ones. So you can make matrices like this also, immediate matrices. Um, the matrix that, someone wanted a random integer matrix that is given as grand 3 cross 3 is a size. Then uniform integer is the syntax that is given here. And then you can say the random number is between, random integer is between 1 and 100. So once you do this, you get random integers like this. So yeah, this is about creating matrices. I mean, just blank matrices for operations. I hope this is clear to you all. Any doubts here? Oh, someone asked the question. Okay. U in is uniform integer. So so random numbers are usually sampled using certain distributions. So you can have a normal distribution, you can have a uniform distribution, you can have an exponential distribution. So anything other than uniform distributions are biased. So for instance, your normal distribution, let me use the board to explain. So in your normal distribution, you have something like this. And let's say you're saying between 1 to 100. So this will be your distribution. I hope this is visible to you all. Is it visible? Or do you want me to zoom in any further? Okay, so yeah, you can see this is normal distribution, and you have equal probability of getting numbers anywhere here. So it is just sampled from any point here, and this is your number that comes here. So this is one thing. If it is a normal, so this is uniform distribution. In normal distribution, you have a bias. So numbers close to this section would be, you would have more probability of getting numbers here than getting numbers in this side. So that is your normal distribution. You may also have exponential distributions that are something like this. You may get more numbers between, in the range of numbers near 1, and you will get lesser when it is close to 100. Yeah, so you have different types of distributions. So yeah, that is your uniform integer stuff. Okay. Any other doubts? Okay. Let's proceed. I'll clear this. Now the next thing is to actually enter stuffs in a matrix. So we will also look at something known as nested for loops. So for instance, let's say you need to enter stuffs in a zero matrix. So let's call 3 cross 3. This is your 3 cross 3 matrix. And then to enter values in this, you would say I have a for loop for I goes from 1 to 3. And then for j goes to 1 from 3. So two for loops. So that is called nested for loops. And in that, let us say you are saying that my matrix I comma j is going to have the value. Just pick some. Okay, let's say I plus j. That is your value that goes into that particular matrix. And then you have to end with two end statements. Once you do that, yeah, it is printing every statement because I didn't put a semicolon. So towards the end, you can see this is your final result. So let me clear this once again. Now, if we print A, this is what is happening. So you can see the index. So this is 2 comma 1. So you'll have 3. This is 1 comma 2. The index of this place. So you can see 3. 3 comma 1 is 4. So the maximum that you can get is 3 plus 3, which is 6. You can just include any kind of logic right here to get your values. This is a nested for loop. And one more thing is, one more thing that came to my mind is you also have to sometimes write values in a reverse order. So let us say you have a vector that is say zeros, 1 comma 5. And now you need to enter values in this vector in the reverse order. So let's say 5, 4, 3, 2, 1. So for that, in your for loop, you would say for I is equal to, let's say 5 is the last value. So 5, or you can say length of V. Length of V. This is also, you usually you'll never write 5. Even here, 3, whenever you're writing for loops, if it is 1 to some number, that number needs to be specified well. So here 3, I've just written it here, but it is a good practice to write the length of your matrix or variable. Here the length is 5 of your vector. So you write 5 from 5, and then minus 1 means it's going in the reverse direction. So last time, if you remember, we just did 0.5 here. So it was like incrementing by 0.5. Here it is going to decrease by minus 1. And then if I just press 1, you can see V is VI. Just say the reverse order, dollar plus 1 is equal to dollar plus I is equal to I. Oh, yeah. Okay, dollar was not the right command. Let me recreate this. I'll just say I. You can see, I mean, it's coming from the reverse order. So I didn't put the semicolon so that you can see how things have been entered. So 5 was entered, then 4 was entered, 3, 2, and 1. So this is the reverse order of printing. You can, just see once again like how it prints 5, 4, 3, 2, 1. It prints in the reverse order instead of the ascending order. So you use this -1. You can also use -2, -3. If you use -2, it will be like 5, 3, 1. And then it will stop. So this is the reverse order. And the final stuff that we need to see is a case that is usually not used much. It is called select case. And yeah, so I'll go to the script section for this because it'll be easier to write stuffs here. So if I say A is 2, then I'll say a select case. So I'll select A. And then in this, I have cases. If I say case 1, if A is 1, it selects A and then checks if it is 1. If it is 1, you can say that, okay, then you can say this is display high. Then do case 2. So this is the statement for it. And then once you do this, save and run, you will see case 2 has been picked because A was 2. Yeah, use semicolons. I usually tend to forget, but you have to use it. So this is about select cases. You can also include ranges here. So let's say 1 to 5, 6 to 10, and then run it. Yeah. Why is this coming as pi? Okay, I think it's specific to a particular number. So you can just write a particular number and then change the orders and see. Yeah, you can see high has been displayed. So this is sometimes useful, but I would recommend to never use this. It is good for your knowledge, but if you are using some switch cases, like if you want to program buttons in a particular code where like you want to do a select, then and you give them 2 or 3 options, that time this is good. But for our chemical engineering purposes, we won't be needing this much. Okay, so let us go to the uh, problem sets. So for today's session, it'll be like mostly you guys would be coding. I'd be just observing what you guys do. So I've given a list of problems already, so you can have a look. So these are the problems. These are basic problems, and I have covered all whatever you need to solve these problems. So these are all very simple stuff. It's all about slicing and then usually working with matrices and all those stuffs. So just have a look. You can solve the first one. I hope you're all ready with your SCILAB sessions. You can work with this. I've also given the PDF. You can download it and have a look in case you're not able to view it properly or something like that. So you can work on this. So here, let me explain the first problem. So you have a heat exchanger network. So typically in a heat exchanger network, you'll have 4 streams, and you will have a hot inlet, uh, cold inlet, and outlets for each of them. So 4 streams. So those 4 streams are written here and it seems like there are I mean, there are three heat exchangers here, and heat exchanger has its own inlet outlet values. So the first thing that you have to do is to find out the temperatures of two streams, the first two streams, because yeah, so these are heat exchangers, these are streams. The streams are going to be these stuffs here, two streams, and then you have to calculate the average of each stream. So I had shown you this mean value, and then with that you can find out the average of these streams. And then the last one is to reverse the order. So I had shown the reverse operator. So you can also create another matrix and just input these values in the reverse order and store them and display that matrix. So that is your first problem for today. You may start writing the code. Once you're done, please, whoever finishes can share their code in the chat section. It shouldn't take more than 5 minutes. What do you mean by the normal arrowhead? You need to, so once you write for loop, it'll wait for you to write your end statement. So once you hit end, you will get back your normal uh, arrows. So if you use three for loops, it'll expect you to write three ends. And once you write the third end, it'll stop over there. And don't bother about those arrows because we won't be writing for loops on the console. It's good to always write it on a script. Anyone done with the first problem? I'll wait for a couple of more minutes. Yeah, correct. The first two are correct. I'll show you the answers. So, so for those of you who are curious to know what this is LaTeX, and this is what people usually use to write your. I mean, almost 90% of all of your standard textbooks are written on this language. And this is a type setting language, not a programming language. So you can see all crazy stuff's written here. It's just easy to write big documents in LaTeX. So I already have the answer written here. So you can see temperature was, so who posted that? Yeah, just as Mythili has posted, you guys can see here the same stuff. You write the matrix as 100, 200, 300, 400, and then extract the uh, first two columns. So for columns, you'll write for all rows, and then you put a comma. So all rows means it takes 100, 150, 200, all these rows, and 1 is to 2 means the first two. Then you have the mean temperature. So if you remember, we calculated the means through two different sides. One was like taking mean in this direction, one was the other direction. If you put R, it comes in this direction, R or 1, either of these. So you will be able to take averages on this side. And the reverse matrix is something uh, maybe you can spend some time figuring out what this thing is. So they create a separate matrix called reverse matrix. And in that matrix, you take the temperature matrix, take all rows, but feed in through the last value of the matrix. So it takes the fourth column, then does minus 1, that is 4, 3, 2, 1. In that order it stores. So this is your reverse matrix. So you can copy this down for those who haven't completed. And do a display. I mean, here I have not written the display lines. So you can do it by yourself to see the actual answers. Okay, any doubts in this? Okay, third answer. Yeah. So, okay, you want this. The reverse order, it means that just print the entire stuff as 400, 450, and 500. So let us go to. So what is happening here is you have your temperature matrix. This is your temperature matrix. And then your submatrix is going to be this thing. So you sliced off the first two columns. Then following that was your average value. So in this, we took the average of 100, 150, 200, which is going to be 150. The same for all the other things. That is what this R means. And the final is reverse matrix. So in this, we are creating a separate matrix. So let's just print this and see what comes here. So I'll clear this, press the temperature matrix, and then take the reverse of this. So this is just printing it on the reverse side. So all the all the rows are going to be the same, but it starts with dollar. Dollar means the last uh, column. The last column is having an index of 4. So index means it starts with 1, 2, 3, 4. It's on the fourth column. 4 minus 1 is, so first it will print the fourth column. Then minus 1 means it's now coming to the third one. So 4, 3, 2, 1. So if you see 4, 3, 2, 1 and 4, 3, 2, 1 here, you can see that it's exactly reverse the order of your matrix. That is what we have printed here. So this is your answer. So you'll be doing a lot of stuffs like this You'll have strange logics with just these colon operators, dollars, minus signs, and all of these. Yeah, so we'll be doing a lot of, so those who have not understood, don't worry. We'll be doing a lot of examples that have these things. So keep in mind dollar sign means it's the uh, last column or row wherever it is placed. If it is dollar on the column side, that is the last row, last column. Sorry. Yeah. So I hope that clears your doubt. Does anyone else have any other doubt or are confused somewhere? Yeah. Is anyone still writing or can we move to the next problem? Okay, we can move to the next one. Those who have the PDF can, if they're finished with the first problem, please move on to the other one. Um, I mean, it's going to be simple only, don't worry. Okay, so here, this is your next question. So you have a reactor feed composition and it has these, so components are your columns. So you have three, it seems that you have three products which have these three different compositions. If you add them up, it'll come to one. And you have three streams. So these rows are streams, components are columns. Adding up them on this particular, I mean, if you add them column wise, you'll get one. So you have the first question is extract the composition of the second feed stream. Since your set stream is rows, so you'll be extracting the row number 2 out here. Row 2 is what we'll be extracting. Then determine the total composition of each component across all feed streams. So you'll be finding the summation value of these. So last time we did mean, this time do summation to see what your values are. So yeah, you can sum them up, or is it norming that I need to check? Yeah, for now, just sum it up. We'll see if we need any changes out here. Since we don't know if these are fractions or concentrations, just sum it up for now. And then add this new feed stream composition to the matrix. So you need to add it as your fourth row. So work on this. Okay, okay, let's look at your, I mean, this is also right. We look at your answers. So I can cross check your answers. So let us work it out here once again. So for those who haven't understood, let me clear everything and then run it once again. So now composition matrix is given. This is what is given to us. Then you have the second stream composition, which is going to be your second row. So it is extracting this particular value. So you can see 2 comma all columns is the second row and all columns 4.3.3. And total composition is given in this direction. Uh, yeah, it is summing up these things. So you can see 0.2 plus zero point 0.4 and 1 is 0.7. And yeah, so that is your total composition. And your updated position matrix is this thing. So you are just adding this 0.3, 0.3, and zero point 0.4 to the last row. So that is this thing. Yeah. So any doubts here? Anyone stuck in between? Syntax error in last. I mean, you need to check what you write. Somewhere you might have missed something. I'll be uploading these results on either GitHub or somewhere. I'll let you know. So you can copy these once you get them. Just check once again if you have entered stuffs right. And it's good to comment in your code because let us say you write the code and then someone else has to deal with it. Usually, once you start writing long codes, it is like it won't be with you only. There'll be like plenty of people who will be looking at the code at the same time. So if you comment out some stuff, like if you're editing some part of the code, it is good to comment to make the other person understand what's going on. Otherwise, such numbers and all, no one will understand what this thing is. If I just showed you this, no one is going to understand what's going to happen. So it's good to write comments. It can't be that you are not getting it. It has to follow this. You can check, or is this not working? Yeah, Chatut, you're also right. Anyone else facing some problem? You might have misspelled something here, so you might have got a syntax error. The syntax error itself would indicate what is wrong. So for instance, if I just put some trying like this, some wrong answer here, and then run it, see, it will give you this error, and then it will say unexpected end of a line because something is wrong here. So you know that there are two quotes that are placed out of context. So errors, I mean, you'll usually see why it is, and it will give you the reason. Okay, so let's move to the next problem. Does anyone have any other doubts? No, sir. Okay, I don't know. I mean, if you have some doubts, let me know, Sahil. Or if you're fine, just put a thumbs up. Okay, fine. Is anyone still solving this problem? You may raise your hands. Okay, fine. No one is solving it. It seems like all are quite fast. Okay, so let's move to the next problem. Yeah. So this is the polynomial part. So you can see you have a polynomial equation. It seems like some rate constant equation, just some random values here. I don't think this is going to really be significant to some physical quantity. But yeah, you can see it as 2 times t square plus 3 times t plus 1. You have to calculate the rate constant at t is equal to 300. So what you would do is first create a polynomial. So you'd write poly and then you'd write 1, 3, 2, and then put in a single quotation of x and then coefficients. Like how we created this polynomial last time. I'll write the code for this. Then you can generate, use this polyval or what, Homer or Hermer was the name. You can use that function. And Horner. You can use the Horner, put that polynomial in that, and then enter this vector, and then find the derivative of the polynomial. The name of derivative is just derivate, derivat, and then enter your polynomial. It will find the value. So just to start, I mean, people who might have not followed, the polynomial would be poly 132. The variable is x, and these are coefficients. You may proceed from here. Okay, this is also fine, but use the polynomial function. This is what we would usually do. You're correct, Gaurang, but use the polynomial function. See, because for instance, look at this dk by dt. Let's say you have some very long polynomial. You would be wasting time just calculating the derivative by hand. So, and the main purpose of using computers uh, is to like stop your hand calculations and let the computer use its brain rather than you using yours for calculations, particularly. Other stuffs, yeah, logic and all you have to provide. Yeah. So start with this thing. So let me just write the answers. Polyval of polynomial. What was the 300? So this is your answer. And then you have this other function which could take vector input. Even polyval does take vector inputs and can take the derivative, give some name for this y, and then use the same polyval function at 300. So these are your answers. Does anyone have any doubts here? I'll display it in the. You can use Horner or polyval. So both work. So I mean, now you would ask why are the two functions that do the same calculations? So again, it comes to the development of such algorithms. So I mean, I guess polyval would have been the original function. I mean, the backend function that would do these calculations for polynomials. Then there would be a separate group of researchers who would have like come up with a much faster algorithm, and maybe that's why you have two different codes. I mean, two different functions for this. So these things are called functions. We'll be doing this after we finish this the first assignment, which is based on these vectors, matrices, polynomials, and also the loops. I hope this is clear to all of you. Anyone still stuck here? The others, Kushi, Archit, Sahil, Malab, Sandeep, you're all fine? Okay, fine. Let's go to the next problem. It is your mass balance. You have three streams, so streams are marked as 1, 2, and 3, and flow rates are given. Extract the flow rates of the first inlet stream, which means find out this 10, 15, 20. Calculate total flow rate for each inlet stream. Sum them up over your row. I mean, use R as the argument. And then if flow rates of the inlet streams are doubled, how would the flow matrix look like? Just do two times of flow matrix. It's a very simple example. So I'll give you about 3 minutes to solve this. So slice the first column, sum over rows, and then just double this matrix. Okay, I hope you would have done this. Anyone with the answers? Yeah, fine. That's right. Yeah. Yeah, so this is the given flow rate matrix. As I said, the first column is going to be all rows, first column, 10, 15, 20. Summing over, summing over your columns is going to be R. We have done it thrice already. And double flow rate is just two times your matrix. So nothing special in that. Now comes a system of linear equations. You have AX is equal to B kind of a form. So you can see a matrix, it's going to be 2, 1, 1, 3, and here is 3 and 2. So this is your matrix A, this is your matrix B. So you just have to do A backslash B. Oh, that is something which I didn't tell you all. So if you have two matrices, so let us again pick some is so A solution of this is going to be like this. A backslash B is finding X. That is A inverse times B. You have Mehul, you have squared your matrix, flow matrix. You have to do it twice. So just correct it there. Okay, fine. It is star. Okay, fine. I just saw it as a power. You're right. In the meanwhile, you can just solve this. A and B have been given. Part 3 is redundant. So it's actually printing the same matrix. So if you add something extra, then maybe it would have made sense. We can skip part 3. It's a very simple solution. Anyone having doubts here? Are all of you good? Anyone still doing this? Someone having some difficulty for solving a system of linear equations? So this is something that comes a lot for chemical engineers. You will have multiple. I mean, while doing material balance, you will only come across systems of linear equations. So flow rates going in one stream, then separating, then it reduces, and then again joins. You have a purge stream. You will have a mixing stream. All of these, when you calculate the flow rates, you will have a system of linear equations, and that will be quite a large matrix. And then you have to invert that matrix to get, yeah, so A inverse B is what you'll be able to calculate as X. Yeah, so again, here for systems of linear equations, you will come, so you will have something known as a sparse matrix. So most of the, so if you just calculate the matrix for a very large, I mean, you have, let's say, hundreds of pipes that are going in your field of study. So, so what will happen is at any junction, there might be just, I mean, let's say max 6 pipes that are interacting with each other. And the rest pipes are mostly going to be, I mean, since at that junction there are just 6 pipes, all other pipes at that point, the flow rates are zero. So you will have very sparse matrix. And let's say that so if you have 100 interacting as unit operations, you'll have 100 cross 100 matrix. And inverting that would be a very lengthy procedure. So the computer will also take time. So all these 3 cross 3 and all what we know to invert as A inverse and all, you might have done those calculations. That is fix one, take the determinant of the matrix 2 cross 2, which is not lying on the rows or columns of that particular element. I mean, you might know the inverse algorithm of a matrix. So the bigger the matrix gets, the lengthier this algorithm also gets. So, so yeah, 100 cross 100 itself is a very lengthy calculation. Computers will take time. So people again work on these algorithms. There is another algorithm for inverting an inverse of a matrix, and people have like reduced it further. So they say in the order. So you might need let's say 3 for loops for solving this. So it takes some time. People just I mean they work on this field and find out more efficient algorithms to just invert this matrix. And of late, I guess the power of 2.25 is the fastest, if I'm not mistaken. So yeah, you have algorithms for that. Um, the general one, what we do has the order of 3. So yeah, I mean these are all little advanced discussions on these matrix inversions. But yeah, you will soon realize it once you deal with a very large system. So this is your answer. I hope no one has a doubt. Yeah, no one even saw has written it. So I mean, I'll wait for a minute. Those who want to copy it down. So display these values in your system, and you'll be able to understand what's happening. So on this display, these numbers are all line numbers in the code. These are code blocks. These are line numbers. So these are not in the same line. I mean, these are in the same line, not in different lines. Yeah, fine. I don't think anyone would take a lot more time than this. Let us proceed ahead. This is your distillation column design. Someone has written something. Yeah, I think lin solve, that is what we did last time. So that is the function that to write the system of linear equations, and then Scilab rearranges it in standard matrix form. Okay, you want to write the equation directly like AX, then I mean, you want to write this equation directly. Where is this? You want to write 2a plus b. I mean, this is what I understand from your question. You want to write 2a plus b is equal to 3z, 2a plus 3b is equal to 2z, and then that would solve your problem. I hope that is what you are expecting. Yeah, okay, fine. I don't, I mean, uh, that is again a lengthy procedure. I mean, you won't do that. It's easier to just write it in terms of matrices. People are, I mean, so for instance, in chemical engineering applications, for instance, your the data that you get. So industry data is like quite complex. It is called big data. They give you data of flow rates, uh, and then they wouldn't give you compositions, or sometimes so data will be either it will be available or it will be missing. So the best thing that they can provide is fractions. So they'll say this is one particular stream. Let's say you have an oil pipeline. They will say that the split ratio is 2:1. So with that data, I mean, you can't write something like A 2A plus B is 3Z or something like that. If it is a reaction of, obviously, we are not dealing with I mean, a system of linear equations. You have rate terms, it becomes complex. It is actually a system of differential equations which we have to solve it separately. But for these split ratios and all, I think the best way is to like directly write the matrix itself. So that is what you'll end up. And I mean, I'm not sure if anyone would even want to write a system of a linear equation directly. The best, I mean, if you're too lazy, you can just tell ChatGPT to write it for you. It'll separate the matrix file. Okay, I hope that answers your question. Uh, yeah, we'll move ahead. Again, distillation column. Stages are rows here this time. So you have three stages and three components, and then find the concentration of the first two stages. Again, slice up this thing, slice up 1, 2. Calculate the average concentration at each stage. But this time, mind that the averages are in this direction. So you'll use mean and then write C instead of R. And then transpose this matrix. So transpose is just dot T, or you can just put prime in before your concentration matrix. That is going to give you the transpose. This is also again a very simple problem. So the thing I want you all to do is, I mean, the purpose of you repeating the same slicing arguments is that you guys get quite comfortable with this. because in any kind of code that you come across, you'll be doing these things only, slicing in between and finding all these. So, for instance, you have this matrix multiplication algorithm. So, one is a tri-diagonal algorithm. Uh, so, instead of really, I mean, it's for a very specific condition where you just have like at any point you have just three species interacting with each other. I mean, three streams interacting with each other. You will just find that all the diagonal and off diagonal elements would be filled, and all the other, I mean, the further elements, it will be zero everywhere. Just the diagonal and the first off diagonals would be filled. In that case, you have an algorithm which solves such matrices fast. If you do this a backslash b in that case, it will take a lot more time than the uh, algorithm that you use. So such algorithms, I mean, you come across algorithms that are faster. I'll just write that down. Those who might not understand. So if your matrix looks something like this, you have elements here, one, two, three, four, and then you have the off diagonal elements. And this goes to infinity. And you have it like this. Only these elements are there, and the rest are all zeros. And for this, if you do a backslash b, this time will be a lot more. So the time, let me write time. Time for doing this operation would be a lot more than the tri-diagonal algorithm. So the research work usually goes around, I mean, mathematicians do these things. We just read their research papers and see which is very suitable for our case. You might not get a matrix that looks like this. Somewhere you'll have an element here, means you can't use this. So, okay, someone has solved this. Okay, let's look at the solution we have. This is also a pretty straightforward problem. Matrix is written. You calculate the concentration of this matrix. Uh, yeah, I mean, you were asked for the first two rows, and this is the algorithm. You find the mean of this, and the transpose matrix is concentration matrix prime. So yeah, it is green in color, but yeah, just to be prime. So Archit, you haven't done it for the transpose, is it? You can just write prime over concentration matrix. For those who haven't done it, yeah. So coming back to inverting large matrices, I can give you an example from my PhD topic where I have to invert a matrix which is 100 cross 100 and each element is a 3 cross 3 matrix. So that is roughly around 300 cross 300. It takes more than 2 days to just invert that. So you can imagine how much time these things take. Okay, fine. I think you guys would have done this. Archit has given the answer. Thanks for that. And anyone has any doubts here? You all are good? Fine, we'll move to the next problem. Here we are dealing with vectors. Again, instead of matrices, just do it with vectors. The vector is given. Slice the vector for the first three time points. Let's say this has some time values. Say 1, 2, 3, 4, 5. Just give a random time value for this. And then calculate the rate of change. So if you say time is 1, 2, 3, 4, then just do DIFF of this thing. So that is your rate of change. And then you can plot your concentration versus time. So diff is allowed only if you say this is 1, 2, 3, 4, 5. If you want to make it 0.1, 0.2, then you do diff of both because it is dc by dt. So if dt is 1, if we say 1, 2, 3, 4, that means dt is 1. So you can just do the differential of this. And then plotting is something that you guys have learned. Just calculate c is given, t is 1, 2, 3, 4, 5. Just to plot t comma c. So anyone with the answer? Is the previous one. Yeah, Chatut, you have done it right. Yeah, this is how exactly you're supposed to write. I'll just give the answer since the answer is already in the chat. This is an additional line. I mean, if you want, you can write. You can also omit. Um, I would rather omit this one. Need to confuse you guys. Your time can be written like this instead of 1 to 5 because we may be changing the shape of your concentration vector depending on our requirements. If it is given that concentration is measured at equal intervals, you can go with this formula because if you change that, this will also change. So any doubts here while plotting? Anyone stuck somewhere? Okay. Oh, I didn't realize that these thoughts meant. Okay, fine. Yeah, this is also right. Do label your plots, give a title name, label the axis. So let me also do it. You'll get something like this, quite linear. Zoom in, zoom out. They are on this. And do label it properly. So this is it with this problem. Does anyone have any other doubts here while plotting? Is there someone who's still solving this thing? Please raise your hands. I'll wait for you guys. Or if you're stuck in any of the previous problems. Okay, fine. What about the others? Who all are there? Ritika, Urmi. Haven't heard from you guys. Parab, you're all. Are you all following? Some thumbs up. Raise your hands. Something. Fine. Uh, okay, let's go to the next problem then. Yeah, the number of tanks are given through rows. Uh, Find the composition of the second tank, the same stuff. Do it for the second tank. And then the total composition across all tanks. Sum it up over your by keeping R and then normalize. So does anyone know what normalize is? I mean, I expect the fourth year students to answer and just guide. Someone please just write what normalization is. It is not, you can use norm, but again give the direction, but just write what norm is. In this particular case, write what norm is so that your juniors can understand. So no seniors here, final year students. Come on, your juniors want to know what norm is. So this is your normalized values. 2 means C. Okay, any doubts here? I can run this for you guys. You can do this individually. To be on a safer side, I'm just writing it in this format. I'll revise this and get back to you guys. As of now, we don't have much time. Okay, we'll look at the next problem. So you can work on this. Just yeah, you know what A and B is. You can work on the third one later on. You can use norms as well. I guess norms would also work. And here, yeah, so do the polynomial thing, the same stuff. Use Horner to calculate the value over here, and then yeah, you have to use it twice, and then see yeah where you will find this maximum value. So how do you calculate the maximum? You will have to take the yeah. Does anyone know how you will calculate a maximum from a parabola? I mean, these things you need to know really well. You are given a parabola. You are given an equation. Find the maximum of that equation. Given that it shows a maxima. So in this case, I can see that this x square is minus, I mean, t square has a negative number. So I guess that is going to show a maxima. So does anyone know how to calculate maximas of these things? So the answer is a derivative. So at that particular maxima, derivative would be zero. So, I mean, you have done this Horner. So I'll just give you the answers of these. I'll not make you wait further. We'll just go through the other answers as well. So since we have discussed this, we can just look at the answer directly. Yeah, this is your polynomial equation. For the first part, you have done 100. Second part also, you have just substituted this in the Horner equation. And at this particular value, you take the derivative and then find the roots. So at the derivative, you'll have the value as zero. So any equation equal to zero is like finding the roots of that equation. So use the roots function here. So I hope you understand this. And the next problem is a wastewater treatment plant has multiple treatment stages, and you have a matrix representing the pollutant concentration at each stage. So you have stages as rows and the pollutant uh, on the columns. So again, extract a submatrix showing the first two stages. Stages are rows, means the first two rows. Calculating average pollutant concentration at each stage is going to be the mean of these values at, I think you can use C over here, and then determine the reduction in pollution concentration from first to last stage. So you can see 70 minus 50. That is what you have to do, or whichever is first to last. I'll just show the results. So submatrix by now, I guess I don't need to explain. Then mean is over C. This is what I said. And then, yeah, the reduction is pollutant matrix at the last row minus the first row, which is 70 minus 50. Good to use dollar signs. So that's it. We have done 10 problems on slicing and all these things. So I hope you won't have any issues with these things ahead. Is it clear? Those who have the PDF can sit and work those two questions out. Any other questions? Any other doubts with slicing? Yes. Ayan? Okay. If you're typing, I'll wait for you. Otherwise, if anyone else has any other questions, please do type. Okay, you're fine. Good. Um, so if you don't have any questions, we'll take a break, return after 15 minutes. Okay. Yeah, you can keep, if you are interested, you can continue solving the other problems. Yeah. We'll meet after 15 minutes. Bye bye. Yeah, hi. Let's continue. We finished with matrices, vectors, and polynomials. We'll now look at for loops and all the other loops. So let me get this.
Please pay attention, for loops, while loops, if then else.
Where is this? Yeah. So this is your question. The first question is it goes from Ti to. So you're just incrementing delta t in your temperature vector. So just start with t is equal to 100, and then for every for loop, just increment 10, and then you'll get your answer. It's a very simple problem. Just keep adding values to your vector. Anyone with the answer, do put it in your Q&A section. So let's do this thing. So we have a initial time which is 100, and then you have dt. Uh, the increment is 10. So just say 10. Do a for loop from I is equal to 1 is to they have given you as 10 equally spaced segments. So that means you will write 10 here, or the best thing to do is to just write it here. You can say input parameters. And here is your for loop for 1 is to n, and then t of and do 2 as 2 is to n. Yeah, t is I, and then add dt. That gives you this thing. So t of I is equal to t of I minus 1 plus delta t. So this is what we mean by such notations. If you have this in your subscript, you can directly write it in this fashion. But be careful where your loop is running. If the first value is given, and for the remaining values, you just have to ensure that you don't put 1 here. Otherwise, 1 would be overwritten. You'll have something like t1 minus 1, which is 0, and you have no value for that. Your program will crash. So once that is done, ensure you put all your semicolons. And once that is done, just hit on save. And then once you finish this, just run it. And your display T. You'll get your values, 10 values. Or if they say 10 steps, yeah, 10 steps means one more step here. Or is it 1, 2, 3? 9 steps are done. You can add one more step because you're starting with 2. See this run. You'll go till 200. This is your very basic for loop. Anyone has any doubts here? Is it clear? It 10 space segments, so it'll be just 2 is to n. That justifies it. It was given as 10 time steps, then you should do n plus 1. Yeah, this is your code. There are some additional stuffs here. So we wrote this. Here we just initialized. It's good to always initialize uh, your final result. So use zeros. This is a good practice. If not, you can do the way I did. But again, at times when you write longer codes, it may create problems. So yeah, this is the result. Anyone has any doubts here? Is it clear? Okay. Thanks, Ayan. Thanks, Chinmay. Let's go to the next one. Okay, here this is part two. We are using a while loop this time. And so remember, you have statements like break to exit from the while loop, or else you can give a condition for your while loop so that it ends. So if you remember last time, we had discussed two cases of while loops. One is where the while loop ran till a condition was false, and the second one was a while loop ran till, I mean, it infinitely ran till you put the break statement to exit from the while loop. So you can use either of these strategies to get an answer here. If your domain length is given and the distance between points have been given, you know how many time steps are, I mean, spatially how many steps are there, you know. So it is L divided by this delta x. That is your, I mean, the number of steps that you need to take in your while loop. So if you are placing a conditional while loop, so you'll write while, say, yeah, you have to initialize I is equal to 0. Then you write while of I less than this n. So that is your while loop. So and then keep incrementing I. I is equal to I plus 1 inside the loop. And then do your calculation. Here you will start with I is equal to 2. C0 is given. C0 or C1. What did I write here? E1, right? Yeah. I'll change this. So by now you would have realized this SCILAB is a one indexed program. So what does one indexing mean? It means that when you write C of 1, C of 1 is your first index. Whereas if you see Python, it would be C of 0, which is the first index. So you have programming languages that are one indexed and zero indexed. And here, if you want to use perpetual loop, you'll just write while true, while percent %t, and then continue till I is greater than n, and then you should place one if statement inside. And once you place that if statement, if that is true, then you have to break it. Yeah, I'll share this solution file after the class ends. I'll put it on GitHub so that I can maintain version history. Okay, so let us work this out. Again, good to write input parameters. C of 1 is given as 1. Then L is 1. Dx is 0.01. K is 0.1. Any other thing? No. Then we write total number of space steps. That will be L by dx. And for all of these, just put colons. Once this is done, you can start your while loop. So I'll show both methods. So first we start with I is 2, while I is when I is less than n. For this condition, I also initialize C. C is your result matrix. The zeros of the size n. So you can see I'm just writing this over here. 1 minus A star dx. So some things you will notice here. So this is the loop that is going to run. Things to be careful here. You see this K star dx. K is a constant, dx is a constant. I don't want to be doing this multiplication operation n times. So this is actually redundant. I would not want to do something like this. I'll rather cut this, do something like k dx outside, and just write k dx here. Now, do you see the difference? So I'm just getting rid of one multiplication algorithm. So all these things, multiplication, addition, division, they are all going into some logical operators. And in the logical operators, there are like binary numbers. So two binary numbers, I mean, the addition, subtraction, it all happens in binary. And then uh, for every multiplication, like two numbers would come together. Instead of that, just multiply, pre-multiply and keep, and then do this. Even this one I can get rid of. 1 minus k dx is also just just write it as 1 minus k dx. It's a constant. Oh, so why to calculate it again and again? Again, I'm getting rid of one multiplication and one subtraction because it's a constant. Otherwise, sometimes k will also change with concentration. So it is good to write everything inside. But for our purpose, and dx also might change. So this is equally spaced. If it is like some logarithmic distribution, I mean, it's all based on grid spacing. So if your grid spacing is, I mean, it can be equal, it can also be non-equal, and yeah, different ways are possible. So once this is done, you can display C. I would display the first 50 or first 50 is fine. Okay, I missed this. NX, yeah. NX. Oh, this is going forever. I have to also. So one mistake that I did is I didn't increment I. So it was going on forever. Yeah, this should give me my answer. Yeah, you can see how concentration varies. Just plot it. So this is your result, and do also label them. The other way is going to be two different methods of using while loops. You can use either of them. You have an additional if statement here, which is usually not preferred. So this is the best one for our case. This is also dangerous at times. So any doubts here? You can see the same stuff here, what we just wrote. C1 K naught K is equal to zero point 0.1, delta X is 0.01. So instead of doing a number of spatial steps, they are like calculating X is equal to X plus delta X. And if X is greater than L, then this line terminates. And will give you the same result as these two. So any doubts here? Have all of you finished writing this? It seems any reactions from you guys? Are you all fine with this? With while loops? You want to clear something? Yeah, Sahil has some doubt. Wait for him. So I've just updated the code to what I have written right now. So you can see both the versions. Both of them give you the same answer. Yes, okay, fine. Okay, so let's move ahead. So that was about while loops. And next we have the nested for loops. So we are doing this for three different K. So the same formula, I mean, no change in this. The only thing is we are doing it with time instead of space. That is dx, this is dt. And we're doing it for three different Ks. So write the same stuff or you this time use a for loop. So you know the number of time steps that is going to that this thing is going to take, and then you can continue. So let's say the total time is not given, so take it as 10. I go 10 or let me see. Yeah, I can take it as 10. Take capital T is equal to 10. So 10 divided by delta T is the total number of time steps that is going to be looped around. So we'll have the outer loop as this K value. So I'll write it here. Just attempt this and take your time. I mean, it'll take some time for you to understand. So you have for loop for K running. This will be K is equal to, or use some other index. So I'll just write K index. It's running from 1 to 3. Then you have your usual for NT, or rather, I can say for time running from 1 to NT, total number of time steps. And this total number of time steps is given as NT equal to T by dt. And then here you write your formula. Whatever that thing is given, C of should be 2. So C of T is equal to C of T minus 1. Whatever number this thing is continuing. Yeah. And here do minus K, minus K of this K index times delta T is given. Anything else? Times C once again, C T minus. And then end. But write this neatly. Is it visible? Board is blurred. Okay. Please see if something can be done here. Okay, so if you see here, the first line is for K in, I mean, name this as. Okay, if it is blurred, I'll type it. Okay, mirrored also fine. Then I'll unpin myself and just type it here. So your outer loop will go over the index of k. Okay. So you can say something like j is running from 1 to 3. Then you have your inner loop. Inner loop is what we did before. So you'll do for, I'll just comment this, for I is equal to 1 to nt, where nt is total time divided by dt. And then here comes your formula, the same formula that you did, and then two ends. And then ensure that you're saving your uh, C in right matrices. So your initialization of, since you are saving C, you should make it like this. C is equal to, so initializing C is equal to zeros. So use zeros. And then how many zeros do you need? So for every index of k, that is j, you need, so that will be three indexes of k followed by nt. And at every index of, so when j is 1, you need to store everything in 1. And j is 2, you need to store everything here. So the formula will look something like this. C of j comma I, yeah, is equal to C of j comma I minus 1, and whatever is there after this. So the thing is, it'll take k is, and then yeah, your k will be represented as k of j in your formula. K of j times dt, whatever is coming there. So just write something like this. You can also use the previous while loop, but just ensure the indices are placed properly. You can start with C not equal to 1. Okay, so I think it will be good for me to explain what is happening out here. So this is your pseudo code. And then after this, let me write down the initial. And so your K is C is C1, resolve 0. Then you have K, which is 0.1, 0.2, 0.3. Then you have a DT, which is 0.01. Then you have a T, which is 10. But now, for the case of understanding, I'll just put 0.2, which means I'm just going to go through the loop once. The inner loop goes just once. NT is T by dt. So this ratio of 0.2 by 0.1 is going to be just 2. I'll change this later on. So NT is given, any other rate constants have been given. I know C, all of these are fine. Okay, so let me here close. So let us run this one by one. I'm running this. So now you can see all these values. NT is 2. As I said, 0.02 by 0.01 is just 2. Now, since we are done with initializing, these are initial parameters. I need to initialize the solution matrix. So the solution matrix, I want the concentration stored for 3 different Ks. So what I do is, and I'll have NT number of steps in that. So if I change this to, let's say 5, I'll have 5 steps. So for now, let this be as 2. I won't touch that. Just do zeros of C1 was 0 or 1. Let me check once again. I said 1. Okay, fine. This is 1. And zeros, I say there are 3 Ks, or the safest way to write is to write length of K, because I can change K here as well. If I want to write 0.4, I don't have to go to the code to change. I'll change it in the initial parameters. So I say C is zeros of length K. If I just print this, let us see what comes here. So C is a double of K. Length of K is 3, but maybe it's 1 comma 3. Okay, I need to write it as 1 comma K, 1 comma length of K for now, just so that you can see there are 3 elements of K. But now I want NT elements of K. So I'll just write NT. And now run this. You see how C looks like. So I can take this, place it here. You can see how C looks like now. So I have 3 column, 3 rows. I can make this as columns. So just so that I can see it here visually properly. So I'll make NT number of rows and 3 columns. So now you see this 1 is K1, K2, K3. NTs are stored in rows, Ks are stored in columns. Now we need to go till, now let me show how we have, let's say, 5 steps. Save this, run this, and see this is how your final result is going to look like. So you will have, let's say, since C starts at 1, it will be 1.99, 0.98, 0.97. It'll keep reducing like this because concentration is the equation, the nature of the equation is that it reduces. We saw it in the previous while loop example. It's the same stuff, only thing is you have multiple case. So for all 3 different case, we have initialized our matrix and we'll be just entering elements into this one by one. So let us go and write our for loop. So for the for loop, you write for j is equal to 1 is to length of k. This is something that I would do. And then n has come automatically. So we are looping through all k's first. So first, the first k that we are taking is 0.01. This is anyways taking 1, but k of j is going to give me 0.01. So let us go further so that we realize what we are doing. And do for I is equal to 1 is to n, 2 is to nt. This is what we are doing. So we already know nt at at 0 we know, and then we are going for the next steps. I think we need to initialize, make it nt plus 1 because the first case is never considered. And then give all your, so once this is done, you need also, you've been given C1 as 1. So what you do is C of the first row and all columns, that is equal to C1 times ones of 1 comma is 1 row and length of k. So look at what this thing is. Ones of length of k. Let me print everything here. Here this part. So ones of this thing is just 1, 1, 1. If I multiply it with C1 times ones, C1 is already 1. So had it, you can just change your 0.5 and then let's say this was 0.5, C1 was 0.5. This is all 0.5. So you don't have to worry about it. So in our case, it is just C1 is 1, 1, 1. And now this 1, 1, 1, we are replacing it in the very first part of C. C is equal to, C of 1. The first row, this is the slicing argument of the first row here. So you can see the first row, we are going to replace it with all ones. So we are doing the C1 star ones of 1 comma length k. So now you see your C1. What was all zeros? Now it is 1, 1, 1 here. So this is the initialization part that we have done. So I hope this is clear with you all. You shouldn't be struggling here. You'll get through this soon. Yeah. So after this, so your first element has been registered. Then we go to the next element. So that has been done. We need to sort for the remaining part. So the first one was given as NT. So, and I is the index. So I is for NT because NT is here. Looping through I and then J. J is your K. So K is here. So we have termed this as I and this is J. And that's why we are getting C of Ij. And this is equal to C of I comma J minus 1. So if you look at the equation, you see dependence on time only. K is constant. The only thing is we are taking 3 different cases of K. That's why it looks like K is varying, but actually it's a constant for the inner loop. So let's go back to this equation. This is your expression. I need to subtract minus K and here I need to write J. So it reads the right K value. then C of again I comma j minus 1 and then times dt. dt is given. So once this is done, just end your for loop and just print this thing. Valid index. So if you come across such problems, just keep commenting till you get the right answer. You can comment sections. So yeah, this section is fine. And somewhere here there's a problem. So let us look further. Yeah, I guess I found it. Line 25. Let me see if someone has some question. Okay. Let me rewrite this thing. Yeah, this is throwing some error. Let me rewrite this. I minus 1. Yeah, I've been doing the wrong way. My apologies. Yeah, so let me continue. So it will be C of I minus 1 j times dt. Yeah. Yeah, this is done. Now let's see the value of C. You can see it's reducing. So it's running through all different Ks. So you can see you have different values. For the first set where K is equal to 0.1, it went like this. When K is 0.2, you can see it's going as 98, 96, 994, 992, 99. Here it is 997, 994. So it has gone through all three values of K. And now this is your answer. That's it. You just have two for loops. The outer one is running for your, it is running for each K, that is for every K. And the inner one is the usual loop that we saw before as well. The same while loop is just 3 lines of code over here. That's it. So any questions here? I mean, please work this out by yourself. I'll wait for some more time. If you are not clear, please raise your hand. Tracing of code. What do you mean by tracing of code? You want to see the code, or and then finally you can just change the value of t here. T is 10. Once you save, run it, and see the entire list. Explain the loop when it iterates once. Okay, fine. Let me go back to the code. So I'll keep t as 0.1, 0.01. This means nt is 1. And if nt is 1, it is just going through this thing once. Let's save this, run it. You see just two values now. Okay. So, okay. So let's start with j is equal to 1. So let me write it here. So it is going through the loop only once. So first j equal to 1. It has entered here. Now it comes here. What is here? So you start with 2. 2 is to 1 plus 1 is just 2. So I is equal to 2 here. It just goes through this loop once. This loop is once, but this loop will go thrice. So when I is equal to 2, what happens here? You have Cij is what you need to calculate. So I'll just write for j equal to 1, k of j is what? Is 0.1. So in this case, we are taking 0.1 here. Then what is happening? You have so c of I minus 1. So 2 minus 1 is 1. We have already initialized here. So the first value of c, if you remember in your matrix, this is all 1. So what you do is your c value, Cij, is going to be 1 minus 0.1 times 1 times dt. dt is what? 0.01. Is it? Yeah, 0.01. So it is going as 0.001. So your answer is, for your first value, that is c of 2 comma the second row, and for your first value is going to be 1 minus 0.001, which is equal to 0.999. That is what you see here, 0.999. So this has been stored, and now it exits the loop because there is nothing else to follow. Then after this, let me draw this line here so that I know that we have finished this loop. This loop has been done. I'll draw here also 2 lines I'll draw. Means this loop has been done. It has gone through your first, it has gone through this inner loop. Second, this j is equal to 2. This is what is happening now. Now j, it has, so first it went through j is equal to 1 and it went through this loop. If there were like 1,000 times this will continue 1,000 times. And let us say if you had 2 time steps, in the next case, it would be like, I'll write here only, if there were more, if there were more time steps, then C of 3 comma 1 would be 0.999 because that is your C of 2. You see here. So if I just put 3, 3 minus 1 is 2. So 0.999 minus K is already 0.1 here. So it won't change because we were in the same loop. then this is equal to 0.999, then multiplied by 0.01. dt is constant. So you can see again you have a very minute correction to this, and that will give you that 0.998. To work this thing out, we'll get the same result. Okay, so let me go to j is equal to 2. So I'll write it here. For j equal to 2, now your k of j is equal to k of j is equal to 0.2 now. So this value, so your c of 2, c of 2 comma 1 is now equal to 1 minus 0.1, 0.2, because k is 0.2 now. 0.2 times 1, that is your c. So we did 0.2 minus times 1 into 0.01 times 0.01. And this I'll just write it here is equal to 1 minus 0.002, which is equal to 0.998. So if you see here, this is 0.998. And since nt is just 1, so 2 is to 2, this loop exits. There's nothing else to continue. Then it goes to j is 3, and the same logic. It'll enter j is equal to 3. Then here, when j is 3, k of j is equal to 0.03, because here you have k of 1, k of 2, k of 3. So k of 3 is 0.03. And then again, it goes through this loop once, and then it's done. So this is what happens when you run it once. And then when once this is set up, you are free to just change this value. You don't really have to worry about what is going on. If I just make this as 10, it's all sorted. Just run it, you can see 1001 steps, including the initial step. It goes for a quite long time. So all these are sorted. So did you understand this? Is there any more explanation needed? Okay, great. Anyone else has a doubt? I mean, it's very extremely important for you to understand this, because there are loops where you might do multiple loops. So for instance, those who did the Excel course, you might have seen that there was one particular case where you had 8 loops in the NRTL, non-random two liquid equation. If you try to code it, you have 8 nested for loops inside there, and you need to be extremely alert uh, to ensure your indices are not missing off anywhere. So this nested for loop is very, very important for you. If you master this, you have mastered programming. That's it. So yeah, please go through the problem once. I'll give you time. Now try to do it without looking. And if you're stuck somewhere, let me know. If anything is not clear, do let me know. Yeah, so Mehul seems to have understood. Others, okay, Ayan has some. Do you have some doubt, or is it like last time? Okay, fine. Okay. Sorry, Ronak. Hmm. Okay, please try this on your own. Okay, let me see what solutions I have here. I think since I explained, I'll replace the solution that I gave you guys. So the same code you can write in 4 or 5 different ways. There is like not just one particular way to write to get this answer. So for instance, last time, I mean the same code, you can just make this as your while loop and continue. And while loop, you saw there were like 2 different ways of doing while loops. So my overall recommendation for you would be always, I mean, you always have to use for loops. If it is, I mean, just avoid while loops because they are known to create problems. And within for loops, sometimes you'll have to keep if else statements. So that also reduces your speed. The more number of for loops are there, it scales. I mean, the problem will scale in that way. So usually they say orders of, um, I mean, the order of the problem is always k times nt. If you have multiple loops, you will have k times whatever. And usually people do square matrices, so they would say nt squared, something like that. And they say it's of the order of 3, order of 4. Order of 4 means there are 4 for loops. So that is the complexity of the problem. The number of for loops for now, just I mean, just take for granted that the number of for loops is equal to the complexity order. Here, the complexity is actually 1 because this length, this k is very, very small to nt. So nt is just going, so you are just looping through it once. So the order is 1 and it depends on nt, the number of nt's. Yeah. You will realize this if you do that tick and talk like I did yesterday. Okay, so once you're done with this, let us go to the next one. Um, this is an if-else statement. Yeah, you can try this as well. So you have a tank which is being cooled by a circulating coolant. You have, okay, so this is again the same type of reducing values. T of coolant is given as 25. T is something which is reducing from 100 and going downwards. Delta T is constant. Here I have I not given delta T? Just assume it to be 0.1, 0.01 or 1. It's up to you. You can change whatever you want. Total time is given. Number of steps can be determined in the similar manner. What did I have here? 0.01, same thing. So I'll write it here. So yeah, work on this. Here, so what is switching is F. So if T is high, F is 6. If T is low, then F is 3. And if T, and this is the condition for it. So you do the same for loop. You have this for loop. It looks just the inner for loop you have to keep in mind. In this section, you will have this just one index, not two, like the one here in this thing. It will look something like this, the same stuff. And then yeah, I think this also I need to make it as n plus 1. Yeah, then it'll look nice. N plus 1. Yeah, the same code. Uh, and then you will see that yeah, here you'll be having the flow rates. And once this is done, you have to keep an if else statement. I hope you have the question with you. I'll just write the pseudo code here. This is all done. So it looks something like this. Just write this part. T starts with 100. Initialization, you have to do it by yourself so that you get comfortable with initialization also. So here it's going from 2 to nt plus 1. So your zeros are going to have these many values. So always ensure that zeros and this last value are always the same. You won't make an error. If someone asks, sir, is there any function where we write program in sine notes and take the value that we type from console? I mean, yeah, I mean, you can do that. Why not? If it is in the console, see, for instance, let me do something here. So, Control D. Let's say C is, let's take DT, just print DT here. I've done nothing. It's printing DT. Can you see here? The code is just printing DT, and DT was already here. It was on the console. If you are not convinced, let me give you another example. Let's say Z is equal to high. And now this is in your console, Z value. Just display Z in your code. Will get high. So yeah, you can, once it is here, then you can display it. But the drawback is if someone just hits clear, it's gone. And once that is cleared and you run this, it won't work. Running this will give you an error. It will say Z has not been defined. So it is very dangerous to do it this way. So if you're writing in, so write everything inside this. And whenever you're writing codes, yeah, also please ensure to write CLC, I mean clear, clears, close figures, and CLC. This thing you can omit for now. Just write clear and CLC every time you write your code. For now, just try to cross this barrier first, because loops are not easy to understand. But once you get the grasp of it, you will like move really fast. So whoever finishes can, yeah, type it here. So I mean input value. Okay, you mean that. Don't use that. I know you can do it, but never use it. It is actually, I mean, counterintuitive. Why would you? So you have. So what happens is you generally send codes in bulk. So it will not be just this file. There'll be like 10 or 15 files along with this. And then suddenly you just give that input thing somewhere in the console. If you're like writing these codes in supercomputers also, You won't even know where the console is. So what is the point? No one, you won't even be able to enter a value. So better not to use input. I know it looks fancy if you just type input, then like here you just say x is equal to input of whatever it is. I don't know, yeah, whatever input. I don't remember the syntax. If you do something like this, I think I enter a number, something like that. No, enter a number. Like you write 5 and then you get 5. It is fine. You can play with this, but why to do this? I mean, I stopped using this after undergrad. I have never used input after that. We also used to do the same mistake, but it's not a mistake. I mean, you kind of learn how to use these interfaces, but don't do it. It is of no use when you start programming it. Better to just write x is equal to 5 here. If you have some problem, just come back here, just change it here. What people actually do is they will open another text file called the input.txt, and they'll write everything there. So that's how applications are all read. Even this application would have some input file to just place all these boxes somewhere, and that may be in a text file. I don't know. I'm not sure, but most other applications, these engineering softwares that are there, they'll all have this input files. People who do molecular dynamics, they have an input file where everything is being written down, and those softwares will also read it. Similar for computational fluid dynamics softwares, they all have an input file. So I think even, yeah, DWSIM also, DWSIM is object oriented. So I'm not sure if you will have an input file. But yeah, if you're selecting some options, anything that comes like that, you will always have an input file. So does that clear your doubt?
Should we finish now, Aditya?
Yes, sir. Yeah, we can finish. I leave the last, yeah, I leave the last program for you all to practice, or I can give you the answer also. This is, yeah, fine. I'll finish with this code, and that's it. I've already written it, so I'll just. Yeah, so here are your, here's your result. The same thing, if t is greater than 60, you have this f high and f low. This is where your if condition ends. This is your length of your time, and this is how your program is running. And for the case conditions, you'll have a select I, and then you have cases. So it's running between 1 to 11. You will have f is 1. This 12 to 51, you'll have f is 3, else it will be 2. The same code. So that is it. You can look at this program. I'll upload this on GitHub, so that these you can also try these if you are interested. Create functions, but we'll cover functions later on in the next class. So any doubts for today's session? I hope you don't have any doubts.
Nobody has any doubts, na? So we'll finish the lecture now.
Yes, sir. Yes.
Okay. Thank you very much, Aditya.
Yeah, thank you, sir.
Take rest. Okay, okay.